A block of mass 2 kilogram is sliding on a frictionless surface. The velocity of 5 meter per second. Let's draw it first. So there is a block and it is sliding. Okay. On a frictionless surface with a velocity of 5 meter per second. Okay. It has some velocity, say u. It collides elastically with another block of mass 3 kilogram initially at rest. That is, there is a block, another block. Okay. Say this is block 1, so mass is m1, and this block has mass m2. Okay. And the velocity of first block u1 is 5 meter per second. And with another block of mass 3 kilograms, so this is 3 kilogram, and initially it is at rest, that is u1 equals to 0. Find the velocity of both blocks after collision. Okay, the next figure will be like this, the same thing but with some different velocities. So this is mass m1 block and m2 block, and they have some velocities. They have v1 and v2, and this is before collision, before, and this is after. Okay, find the velocity of both blocks. Okay. Both blocks, we have to find the velocities of both blocks after collision. After collision, what will be the velocity of m1 and m2? So now we will use first the conservation of momentum. Conservation of momentum. So what it says us? It says us that initial momentum of the system is equals to final momentum of the system. So what is the initial momentum? Let's write that for initial momentum, that is m1 u1 plus m2. This is before collision. So I'm writing it t, and which is equals to m1 1 plus m2 and v2. Okay. So m1 u1 plus m2 u2 and m1 v1 plus m2. So from this you can easily get some equation that u2 gives 0. So m1 is kilogram, I think. M1 equals to 2 kilogram. It's important to note down the data. It's very crucial thing to solve the problems. So M1 is 2 and U1 is 5. So 2 into 5 equals to M1 is 2 and we don't know V1, plus M2 is 3 and we don't know V2. So there is another equation. So there is equation V1 plus 3V2 equals to 10. But it cannot be solved, and I am writing this equation 1. It cannot be solved because there is two variables. We need another equation, that is, you have to remember for now, that when there is an elastic collision, there will be a relation that is very important, that is E minus E1 equals to 1 minus. The important equation you need for elastic collision. I am writing here for elastic collision. Elastic collision. It works only elastic collision or not other collision. Now from there u2 is still 0, and minus 1 gives us I think 5. Minus 5 then equals to v1 minus v2, and this is another equation. We say we have to solve this equation and we will get the answer. So there is 2v1 plus 2 3v2. We are writing here that 1 plus 2v2 equals to 10, and 1 minus v equals to 5. Can we write this? Minus 5, I mean. v1 minus v2 minus 5. Now let's solve it. So we will multiply and we are getting 1 v2. That is 3vt, I mean 3. There are some problems. 3. So this will be subtracted and we are getting 5 equals to plus, so 20, and from here v2 equals to 4 meter per second, and easily if you put this one, you are getting the v1 also. So v1 is -5 plus v2 from this. Watch this. So v1 plus -5 plus 4, that is -1 meter per second. What it tells that v1 will be rebounded. Sorry, v1, that means this uh, mass or this block will be direction with v1 equals to minus, that means reverse direction. Okay, and m2 was in rest, but it will direction with 4 meter per second. 4 meter per second. Okay, so the answers 4 meter per second and -1 meter per second. These are our answers.